Good evening, online students. Aniruddhan, Laksha, Swati, and Anugraha. Hi, good evening. Good evening, children. Good evening. Yeah. So I had announced a test today. I also told you the 4 type of questions which I shall be giving in the test. So we'll take up the test at 9 o'clock. 9 to 9:30, we'll take up the test. All right. Now look at this question, children. Given, okay, and the other thing is 3 exams have been scheduled for you. I'll tell you how to take up the exams. 3 online exams have been scheduled. I'll tell you how to take up the exams. All right. Now, these portions which I'm doing today is also a part of the portions for the test tomorrow. So listen carefully. Given 1 by 13, the value of 1 by 13 is given to us 0.076923 recurring. You can see the bar it is placed on top of. Is it cold, children? Should I reduce? Should I increase the temperature? Okay. All right. The value of 1 by 13 is given to us. What is the value? 0.076923 recurring. The value is given to us. Okay. Now, given this, we need to find the decimal expansions of 2 by 13, 3 by 13, 4 by 13, 5 by 13, 6 by 13, 7 by 13, 8 by 13, 9 by 13, 10 by 13, 11 by 12, 13 and 12 by 13. Because 13 by 13 is 1. 13 by 13 is 1. So till 12 by 13. We are given the value of 1 by 13. With this value, using the value of 1 by 13, we should find the values of 2 by 13, 3 by 13, 4 by 13, 5 by 13, so on till 12 by 13, because 13 by 13 is 1. So all these values will be less than 1 because 13 by 13 only is 1. So 12 by 13 will be 0 point something. Correct? Okay. Now how do you find? Now write 2 by 13 as 2 into 1 by 13. Is this correct? 2 by 13 is nothing but 2 into 1 by 13 because 2 into 1 is 2. 2 by 13. Now this is equal to 2 into what is the value of 1 by 13 given to us? 0.076923 recurring. All right. Now multiply as if there is no, this is called a bar. Just multiply as if there is no bar at all, you know. Just multiply. So 2 into 0.076923. All right, just multiply. So 2, 3. Okay, or you put it like this. 1 second. Just do the regular multiplication as if there is no bar. So you'll be multiplying 0.07 0.076923 and 2. So how do you multiply? 2 3s are 6, 1 carry. Oh, 2 3s are 6, 2 2s are 4, 2 9s are 18, 1 carried over, 12 13, 1 carried over, 14 15, 1.0. Regular multiplication. Now write that product. Write that product 153846. And the bar is on top of how many digits? 6 digits, right? The last 6 digits, right? You'll have to try. Okay. So place a bar. Now in the given in 1 by 13, the bar is on top of 6 digits. You can see 1, 2, 3, 4, 5, 6 digits. So place a bar like this here. 1, 5, 1, 2, 3, 4, 5, 6 digits. No, it's not displayed there. I have to check the features. It'll be displayed here on the screen.
No, I'm telling.
Or turn it off. Which one is very cold for you?
No, I just want to turn off all the ACs.
Both ACs. I can sit here. Turn off that one. Then that is for this. Try with that. Go closer and point to the AC. Yeah, it's done. Whichever. Is that understood, children? Now, Aniruddhan, Tell me the value of all of you do it. All of you do it. Anirudhan, tell me what is 3 by 13. You can write 3 by 13 as?
Ma'am, 3 into 1 by 13, ma'am.
Yeah, next. That is equal to 3 into, what's the value of 1 by 13?
0.076923.
Yeah, tell me the answer, the final answer. Multiply and tell me.
1 minute, ma'am. Give me 2
Yeah,
minutes, ma'am. இது ஒரு 21 ஐயோ டக்குன்னு வரலையே 27.
Okay, disable your mic. Anirudh.
Ma'am,
Yeah.
the answer is 0.230769.
230769. Perfect. 230769. Perfect. All of us understand how to do it? Yeah, now all of you work. So your steps must be something like this. See your children. See your answer should begin like this. Answer 1 by 13 is equal to 0.076923. This is given. This is given. Okay. So now you should write 2 by 13 is equal to 2 into 1 by 13. That is equal to 2 into 0.769. Oh, sorry, 07. Okay, 3 recurring and write the answer. Like this, finish for everything. Then for 3 by 13 is equal to 3 into 1 by 13. That is 3 into, you understand what to do. Finish it till 12 by 13, all of you. Anirudh, please disable your mic. The regular multiplication, just place a bar, that's all. After the decimal point. Completed all the sums? Yeah, do it. Not these two. I said this one. For this one. For E and H, you can write for it. You can use a property to solve. Finished? Which one are you doing, Roshni? 5 by 13. No? Okay, you? Okay, you? Aragaman? 6 by 13. No, which one are you working? 6 by 13. Is it you? 8 by 13, you? 11 by 13. 6 by 13. 8. 8 by 13. Online students? Which one are you working, Swati? Laksha?
Ma'am, 8 by 13.
Okay. Aniruddhan?
Ma'am, 6 by 13, ma'am.
Okay, you need to hurry up, children. Okay, here, we'll start with Kamalika. Kamalika, share all your answers. What is 2 by 13, Kamalika? Others keep doing your work. Yeah. Okay, what is 3 by 13? 0 point? 0.0. Okay, next one. That's correct. The 33 by 13, I don't know if it's right. 5 by 13? Very good. 6 by 13? Anirudh, have you finished? Okay, sorry. You tell me, what is 6 by 13? 0 point?
Ma'am, you are asking.
0.57. No. There's another Anirudh here in the class. No.
Okay, ma'am.
No, darling. If you are wrong, do it. Okay, let's see. How much have you finished, Anirudh? Anirudh, how much have you finished? Leave that. You've completed everything. All the 8 subdivisions. Last one. No problem. No problem. Your father's come to take you, so leave your papers and you can go. Finished, Dhanvin? Okay. Avnish? Yeah, Dhanvin, give me your paper. Attempted all the questions? Okay. Okay, your father's waiting. Yeah, perfect. Yeah. Fifth one. And you do. Write 5 integers. You go and ask your father if you can complete the test and come ask your father. Okay, you want only the 4th one, is it? Okay, bye. 2. Finished everything? Yeah, 1 second. Yeah, children, it's time to see the answers. Yes, Bhavishya, what was 2 by 13, Bhavishya? Zero 0.153846 recurring. Okay. Roshni, 3 by 13. Aragame, 4 by 13. Zero 0.3. 11, no? No. Laksha, 4 by 13.
Yes, ma'am. 0.307692.
Correct. Yes, Anugraha, 5 by 13.
0.384615.
0.384615, is it?
Yes, ma'am.
Correct. Recurring. Correct. Swati, 6 by 13. Anirudhan, 6 by 13.
Ma'am, 6 by 13. 0.461518.
Very good. Who's finished 7 by 13 here in the class? 7 by 13. Okay, Sahana. 538? No. Bhavishya?
0.538461.
8461, correct. 538461. Who's finished 8 by 13 here? Yes, Prenu? 5384? Yeah, recurring or bar. Very good. 9 by 13. Who's finished 9 by 13 here? You finished, Prenu? Tell me. 0.69. Very good, very good. Yeah. 10 by 13. Niveda, have you finished 10 by 13? Okay, 10 by. No. I think he's waiting outside to take you. Yeah, you can go. He's there only. Oh. அவங்கள உள்ள வர சொல்லுங்க. Dhanvin. You go and tell him to come inside. சார் இல்ல சார் உள்ள வந்துருங்க ஏன்னா தம்பி வெயிட் பண்ணிட்டு தான் இருந்தாரு. இல்ல இப்பதான் முடிச்சாரு ஒரு 5 நிமிஷம் தான் முடிச்சாரு. இல்ல நீங்க இங்க வரல இங்க வந்தாதான் எனக்கு தெரியும் வந்திருக்கீங்க. உள்ள வந்துருங்க என்ன உள்ள வந்தா நான் அனுப்பிச்சு விட்டுருவேன். நீங்க இல்ல சார் 5 to நான் மெசேஜ் போட்டுருவேன் அவங்களுக்கு. 5 to 7:30 தான் கிளாஸ் இன்னைக்கு. ஆமா நீங்க கூட்டிட்டு போக வரைச்சு உள்ள வந்துருங்க அவரு. தேங்க்யூ. Yes, 10 by 13.
0.0769230.
9 to
30 bar.
very good. Ritza, 11 by 13. Doing okay. Finish? Okay, 1 minute. I want Alagamai Kamalika to answer. Roshni also. Yes, Kamalika, 11 on 13. 11 by 13, finished? Huh? Not come there. Okay. Finished? Yeah, tell me. Louder, 0 point? 846153. Very good. 846153. Correct.
Ma'am,
Yeah. Yes.
I think I wasn't audible on the first because I was
Oh,
saying the
yeah,
answer.
yeah. You were not. Now you're audible. Yes, Swati, tell me 12 by 13.
It's 0.923076 recurring.
Perfect. Perfect. Very good. So you can see the answers here. I'll share this slide on WhatsApp, children. You can check your answers. I'll also share the slide on WhatsApp. Check your answers. Shall we go to the next one, children? I'll share this picture on WhatsApp so that in case you need to do some corrections or whatever, you can just help yourself with that picture. Next one. Find 3 different irrational numbers. Now, what are irrational numbers? Non-terminating, non-repeating numbers are irrational numbers. Non-terminating, non-repeating numbers are irrational numbers. So we need to insert 3 irrational numbers between 5 by 7 and 9 by 11. Supposing we have to write 3 irrational numbers, then you can write so many. Okay, you can just write anything, something like 23.23242526 recurring. This is a non-terminating because of these dots, and non-recurring because there's no digit or a set of digits repeating itself. Now you cannot think that because I've written 23242526, you cannot assume that 23242526 is again repeating, because if it is repeating, then I should write it at least once more. I should write 23242526. I should write it at least once more, 23242526. Then if I put dots like this, that means 23242526, 23242526. This block is repeating. At least once more I should write. Simply I write it once and put a dot. You cannot assume that that is recurring. Because how will you assume which is recurring? 2.23, 24, 25, 26. Will you think 26 is recurring or 2526 is recurring? Which one is recurring? So that idea about which digit or a set of digits is repeating should be given to you. We cannot assume something. Okay. So when we write, something like 98.901, 902, 903 goes on like this. When we say this, so what is repeating? You cannot make out that a particular digit or a set of digits is repeating itself. You cannot make out that. It's repeating. It's repeating. Meaning, it is recurring, not repeating, sorry. It's recurring. Okay, it's going on forever. But is any digit or a set of digits repeating itself? No, you cannot make out. Can you say that this is repeating, this only is repeating, 9 is repeating or 901 is repeating? No, you cannot say anything. So this one is a non-terminating, non-repeating decimal. Because you cannot make out any digit or a set of digits repeating itself. But if I write 98.901, 902, and if I write 903, and once more if I write 903 and then put a dot, that means I've given you the clue. 903, 903. That means 903 is going on forever. Because that clue I'm giving you here, 903 and 903. And 903 is going on forever. So this becomes a non-terminating repeating decimal. How do you write this? 98.901, 902, 903 recurring. 98.901, 902, 903, that alone recurring. You cannot put a bar on whole thing. Okay. So that means this one is a non-terminating decimal because it's going on forever. Non-terminating but repeating because 903 is repeating. So this one is a non-term. This one and this one both are the same. Both are the same. This one and this one both are the same. They represent a non-terminating repeating decimal because the digits 903 repeat themselves forever. So this one is a non-terminating repeating decimal. So it's a rational number. It's a rational number. What are the three types of decimals, children? What are the three types of decimals? Terminating decimal, non-terminating, repeating or recurring. Then non-terminating, non-repeating. These are the three types of decimals. Terminating, non-terminating, repeating, non-terminating, non-repeating. The first two are rational numbers. That means it has a P by Q form. This one is an irrational number. This one is an irrational number. Non-terminating, non-repeating decimals are irrational numbers. So if I write 215.11, 12, meaning 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and I just put dots like this. That means this one is a non-terminating, non-repeating decimal. Because which one is repeating? We can't make out. So it's like 161. So from this, what we can understand is 16, so 17, 18, 19, 2021. That's what we can understand. Because 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 and dots means 17, 18, 19, 20, 21, 22. It goes on forever. Non-terminating, nothing is repeating, non-repeating. So it's an irrational number. So if you're asked to give examples of irrational numbers, you should give a non-terminating. You should give a non-terminating, non-repeating decimal, correct? Or you can write something like cube root of 5. It's an irrational number. Or you can write something like square root of 30. All these are irrational numbers because its value. This one is not a perfect square. 30 is not a perfect square. So its value is a non-terminating, non-repeating decimal. Then cube root of 5. 5 is not a perfect cube. If I write cube root of 8, that is 2. 2 into 2 is 8. Cube root of 8 is 2. So 2 is 2 by 1, which is P by Q, rational number. Okay, now coming to this question. So if we have to simply write three irrational numbers, you can write 0.235, 236, 237, like this goes on forever. This can be one answer. Then you can write, something like cube root of 11, fifth root of 7, something like this. But here we have to write three numbers between 5 by 7 and 9 by 11. So you should find the decimal expansion of this one and this one first. You must find the decimal expansion of 5 by 7. You must find the decimal expansion of 9 by 11. See here. Okay, so I have found the decimal expansion of 5 by 7. You should divide 5 by 7. You must divide 5 by 7. You understand that? You must divide 5 by 7. And when you divide 5 by 7, I'm getting 0.714285 again. That means I'm going to get 7. If I get 7, that means again I'm going to get 14285. Again, I'm going to get 71. That is the 714285. 714285. 714285 is going to repeat. I'll give you time to see the division. Now just understand that. See, 714285. Again, you're getting 7. Now you will ask me, how do you know that after 7, 1 only will come? What if something else comes? 5 by 7 is a P by Q form. It is a rational number. So if 7 comes again, then automatically 1 only will come after that, 4 only will come after that, 2 will come after that, 8 will come after that, 5 will come after that. Because 5 by 7 is P by Q. It is a rational number. So its decimal will be terminating or non-terminating, repeating only it will be. It cannot be non-repeating. 5 by 7 is integer by integer. It is a rational number. So its decimal expansion can be of two types. Terminating or non-terminating, repeating only. It cannot be non-repeating. So if we see that its division does not come to an end at all. Its division does not come to an end at all here, right? So what do you see here? 714285. Again, if you're getting 7, you will definitely get the same digits 1, 2, 8, 5. So 714285. 714285 is the repeating block. The minute you get 7 again, that means all this will come again. So that means the repeating block is 7, sorry. Yeah. 714285. So again 714285, 714285, 714285 goes on forever. Now, if you have this question, what if something else is coming after 7? How do you know that after 7, 1 only will happen? The answer for that is 5 by 7 is P by Q. It is a rational number. So it will have a terminating or a non-terminating repeating decimal expansion only. In that case, because 7 is repeating, these only will follow. 14285 only will come. If 7 comes, the same digits will follow. Is it understood? Okay, now see the next one. The next one, 9 by 11, is also a P by Q form. It is a rational number. Either it should have a terminating decimal expansion or a non-terminating repeating. So if you divide, this is what you're getting, 81, 81. So 81, 81, 81, non-terminating, repeating. Now we have found the decimal expansions of 5 by 7 and 9 by 11. 5 by 7 is this one. 8 by 11 is, okay, not like this. 0.81 recurring. I'll correct it. This is, okay, oh, sorry. I should take away this, children. It's 0.81 recurring, that's all. I'll write the correct thing here, 0.714285, that's all, recurring. Then this one is 0.81 recurring. You should not write that 81 again. Only once you should write and put a bar on it. Or if you're using dots, you must say 0.81, 81, and then you can put dots. You should write 81, 81 2 times at least and put dots. Or if you're putting a bar, 0.81 and bar. You should not write 81 again. Bar itself means 81 only is repeating. Correct? 0.81 bar, meaning 818181. Or if you're not putting the bar, if you're using dots, you must write 0.81. At least once more you should write. You can write another time also if you want, and then put the dots. Okay, so first step is to find the, so this is not there, this is not there. So the first step is to find the decimal expansion of 5 by 7 and 9 by 11. So we found that. Now it is something like this one is 0.771 like that. And this one is 0.81. Can you see that? Since I have 2 digits here, I'm taking two digits here also. This is 0.71. This is 0.71. Okay, this is 0.81. I'm taking, since I have 2 digits here, 0.81. Navneet, drink here and go, Navneet. So since I have 2 digits here, 0.81. I'm taking 0.71, 2 digits. So it's like 71 to 81 kind of. Understand? 0.71, 81. So 72, 73, 74. So many numbers you have between. So you can write. So you can write 0. Start with 72 and write anything you want after that. You should write the. You should start with the correct digits. See, I'll tell you one by one. One by one. I'm repeating. Okay. I'm repeating. What is it? Since I have 2 digits here, 0.81, I'm taking 0.71 here. Is that understood? 0.71, 0.81. I'm taking only the first 2 digits. Is that okay? Okay. Now, look at this like 71 and this one is like 81. What do you have between 71 and 81? Because you'll have to write between these two numbers. So what is between 71 and 81? 72, 73, 74, 75, 76, 77, and so on. So let me start with 0.72. Let me start with 0.72. Now, I must write irrational numbers. So I must write non-terminating, non-repeating numbers. So let me write 72. So I'm safe. I'm writing between 0.71, 0.81. So 0.72 is between 71 and 81. So now you're in a safe zone. After this, write whatever you want. Like you can write 141, 142, 143 and put dots. Start correctly. Then you can write whatever you want, but make sure it's a non-repeating decimal. See, if you write 0.41 and something, you're wrong. See, if I write 0.41, 42, 43, 44, you will say, I wrote an irrational number. Yes, 41, 42, 43, 44 recurring is an irrational number because it's non-terminating, non-repeating. It is irrational, but it's not between 0.71 and 0.81. It may be an irrational number, but it should be an irrational number between these two numbers. So you cannot start with 41. If you start with 73, you're correct. 0.73 and write whatever you want. You're correct. So first put yourself in the safe zone and then you can write whatever you want. So safe zone meaning here 0.71, 0.81. So safe zones are 0.72 and anything, 0.73 and anything, 0.74 anything, 0.75, 76. Do you all understand that? So now see the numbers I have written. I've written 0.72. So I'm safe. I've written a number between 0.71 and 0.81. After that, what have I written? 73, 74, 75, so on. So non-terminating because of the dots, non-recurring because you don't understand which is repeating. So non-terminating, non-repeating, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, it goes on like that. So nothing is repeating. Am I clear? Look at the next example. I've started with 80. So I'm between 71 and 81. 80 I've started. Okay, so I'm safe because 80, so I'm safe. So I've written 801, 802, 803. See, 80 I started, that's enough. 0.80. I've taken 8171, right? So 0.80. Are you safe or no? 0.80. So it's between 71 and 81. So you're safe. Look at only the first 2 digits. You're safe. 0.80. You're safe. Now I have written 801, 802, 803, 804, 805. So 801, 802, 803 meaning non-terminating. non-repeating. And then here I've written 7, 9. So 7, 9. Then what have I written? After 7, 9 is between 0.71 and 0.81. So I started with 7, 9, and I think I've written some 7, 9. Okay, I've written 790. Then I've written 7, 9, 1, 0, 7, 9, 2 zeros, 7, 9, 3 zeros. So 7, 9, 4 zeros. Like that it goes on. Don't forget to keep the dots. So you can write anything, like anything crazy. You can write like 7, 5. You can start and write 6, 1, 2, 3, 1, 1, 1, 2, 2, 0, 7, and put dots. Write anything you please and put dots. That's it. Am I clear, children? Online students?
Yes, ma'am.
Yes, ma'am.
Okay, so to insert or to write 3 irrational numbers between 5 by 7 and 9 by 11, we need to first find the decimal expansion of 5 by 7 and the decimal expansion of 9 by 11. That is the first step. So now here we've got the decimal expansion of 5 by 7 and 9 by 11. We got it. Now we need to write irrational numbers between these two. So I told you how to write between them and make sure it is irrational. Not rational, irrational. So that means it should be repeating. So you should put the dots. And also there should be no pattern. Pattern should not be there. So yeah, I'm not repeating that. Pattern should not be there. Non-terminating, non-repeating. Understood all of you? Okay. Now if we have to insert rational numbers only between these two, then it will be like a 0. Like between 7.1 and 0.81, right? Correct. If you want to insert rational numbers, method is different, but I'm saying like with the division how to do. So 0.7, so you can write 0.72 and above. 0.72 recurring. Why is it rational? Because it's non-terminating, but it's repeating, no? 0.72 recurring. So it becomes non-terminating, but repeating. So it's a rational number. 0.72 recurring is a rational number. Because non-terminating, but repeating it is 72, 72, 72, 72 goes on forever. So you can also write 0.7914 and you can just put a bar like this. Or you can even write 0.79 something like 3 and the 3 alone recurring. So just be in the safe zone and write anything you want. Oh, 713 I cannot write because it's 714. Sorry, 1 second. That's why I said we'll safely start from 7.2. So 7.2, then write what? Because safe zone is 71, between 71 and 81. So maybe 0.76. Then some 19 and recurring, or 19 recurring, or 619 recurring. Something repeating. One digit or a set of digits should repeat. So 0.778 repeating. Your choice. Am I clear, children? Okay. So if you have to insert irrational numbers, you have to find the decimal values, meaning you'll have to find the decimal expansions. So you have to perform the long division and then insert the numbers. So so today I'll tell you from when to start writing. These slides I'll share on WhatsApp with you. And you'll have to complete in your classwork. Okay, these slides I'll share on WhatsApp with you. So you can give some other examples if you want. You write what I have written, and then you can write a few other examples of your choice. Division, please try. If you don't know division, then we'll see in the next class, okay? Division, you must help yourself. Yeah. How many irrational numbers lie between root 2 and root 3? Infinitely many. The thing is, between anything, see, I'll write all the possibilities, okay? Between any two rationals, there are infinitely many rationals and irrationals. Between any two irrational numbers also, there are infinitely many rationals and irrationals. Between a rational and irrational also, there are infinitely many rationals and irrationals. We have written all the possible things. I've written all the possible things. Look at this one. Between any two rational numbers, there are infinitely many rationals as well as irrationals. Between any two irrational numbers, also there are infinitely many rationals and irrationals. Between one rational number and one irrational number also, that means between a rational number and an irrational number also, there are infinitely many rationals and irrationals. So for everything, infinitely many rationals and irrationals, whether it is between two rational numbers or whether it is between two irrational numbers or whether it is between a rational and irrational number. For all the three cases, there are infinitely many rationals and irrationals. Whenever it is rational, irrational, infinitely many only. So there are infinitely many rational numbers and irrational numbers lying between two rational numbers. Correct? There are infinitely many rational numbers and irrational numbers lying between two irrational numbers. Also, there are infinitely many rational numbers and irrational numbers lying between a rational and irrational number. All the three. I'll write this again. Between two rational numbers, there are infinitely many rationals and irrationals. Between two irrational numbers, in between two irrational numbers, there are infinitely many rationals and irrationals. Also, between a rational number and an irrational number, there are infinitely many rationals and irrationals. Now, how many integers are there between two consecutive integers? How many integers are there between two consecutive integers? What's answer? How many integers? Online students, how many integers are there between two consecutive integers? Online students, Aniruddhan, Swati, Laksha, and Anugrah.
Ma'am, what, ma'am?
And there is no
Question
integers.
on the screen. There is no integer. There is no integer. Correct. There is no integer because between two consecutive integers, supposing -2 and -3. After -2 is like -3 here, and here it is -1. Between these two, there is no integer. There are many rationals and irrationals, but there is no integer between that. Because what are integers? Integers are like 0, after this 1, then after that 2, after that 3, after that 4. This side, after this -1, then -2, then -3, then -4. These are the integers. Now, between two integers, there is no integer. There are many rationals and irrationals. But between 2 and after 2, the integer is 3. After 3 is 4. After 4 is 5. Now, between 3 and 4, there is no integer. There are many rationals and irrationals, but no integer. Similarly, between two natural numbers, there is no natural number. Between two natural numbers, 4 and 5, there is no natural number. Correct? Yeah. Okay. So be careful with questions like that. Don't write infinitely many for everything. How many natural numbers are there between two consecutive natural numbers? Consecutive means one after the other. Consecutive means one after the other. So between two consecutive, between 10 and 11, how many natural numbers are there? After 10 is 11. There's nothing, there is no natural number between these two. But there are many rationals and irrationals. So what's the question here? How many irrational numbers lie between √2 and √3? Infinitely many. They're not asking you to write anything. How many? Infinitely many. Find any, okay, that's the next question. Find any three irrational numbers lying between √2 and √3. Okay. See the answer? So you should know the value of √2. You should know the value of √3. Memorize the value. And then you must, I'm not telling you this because I've already told you how to write 3 irrationals. So this is like 41 and this is like 73. There's so much of space. It's like 41 and 73. Or you can say 1.4 and 1.7 also. 1.4, 1.7.
Can we take 3 numbers?
Yeah, you can take 3 numbers. You can take 1, 4, 1, 4, and then here 7, 3, 2. Now safely write after that. So if you see, safe is, if you start with 1.5, you're safe. Don't start with 1.4. You may go wrong. Start with 1.5, you're safe, no, because 1.4, 1.7. So 1.5 is so safe. Yes or no? You all understand when I say safe? You don't start with 1.4. You don't start with 1.4. So when you start with 1.5, you're surely between 1.4 and 1.7. When you, this is 1.4, this is 1.7. So if you write 1.5, you're safe. Yes or no? So don't start with 1.4 at all. Start with 1.5. Okay, so see here, whatever, 1 point, whatever written, 5, 1, whatever you can write. Irrational, no? Then I have written 1 with 1.6. Irrational. Then I've written 1. This is 7, 3 anyways. So I've taken 7, 2 only. Stay inside, that's all. So you should know the value of root 2 and root 3. Okay, so find any 3 irrational numbers between root 2 and root 3. So root 2 is this one, root 3 is this one. Between those two, you should write 3 irrational numbers. So they must be non-terminating, non-repeating decimals. You should not write 1.56 like this. And you should not say I wrote between them only. I wrote between 1.4 and 1.7. So I wrote 1.56, but recurring. This one is a rational number because it's non-terminating, repeating. So it's rational. But they are asking you to write irrational. So be very careful. That's about this answer. Okay. You can read the answer. Yeah. No, I have also in my slide. You should write a rational number. So then you should write, if you have to write a rational number, then you must write what? 1.516 recurring like this. But you can write a terminating decimal also. So you can just write like 1.6, 1.7, 1.68. You can write a terminating decimal also. Because the terminating decimal is a rational number. If we have to write a rational number between these two, then 1.5. Yes. Terminating decimal. So it's rational number. Read, children. Read the slide. Okay. Yeah, do this one. Do this now, children. You can take your rough book and do this. I'll send all these answers on WhatsApp. For now, you can do it in your rough notebook. Oh, meaning behind your book somewhere. You do it. Online students can get a rough notebook or a sheet and do it in that. Do it behind. I'll send all the answers in order. Then you can write it in your notebook. So inserting rational numbers, we've already learned in 8th standard. Lower classes, we have learned how to insert rational numbers. To insert a rational number, you don't have to find the decimal expansion. Okay, but to find an irrational number, you have to find the decimal expansion. So see here, if at all you need help. So between 1/6 and 1/7, sorry, 2/7, take the LCM. LCM of 6 and 7 is 42. So 1/6 into 7/7. So 7/42. 2/7 into 6/6. 12/42. So one rational number between these two will be 8/42. P/Q. P/Q, that's all. To find rational number, you don't have to find the decimal expansion. This method, I hope you remember. You have the two fractions, take the LCM and bring both of them to the same denominator. 7/42, 12/42. Now between that, you can write 8/42, 9/42, 10/42. Yeah, you can do mean method. You can add and divide by 2. That is half of 1/6 plus 2/7. Should I add the two numbers and divide by 2? Dividing by 2 means multiplying by half. Mean method, correct. You can do add the two numbers and divide by 2. Divide by 2 meaning multiplying by half. Excuse me. So I'll show you the answer slide here. Sorry, sir. Yeah.
Is it also okay to express a non-terminating and a repeating decimal expansion to express a rational number between 0.16 bar and 0.2857?
Yeah, you can also add it because it's only one. I've written one example. Yes, you can write either a terminating decimal or a non-terminating repeating decimal. See, I'll answer all the questions. 1 minute, children. Please listen to me. Now, supposing we have to insert only one rational, all of you listen. Please stop working. Listen to me, children. Now, supposing we have to insert only one rational number, okay, between 1/6 and 2/7. Then you don't have to find the decimal value. You don't have to find the decimal value. We know two methods. Here, 1/6 into 7/7, 7/42. 2/7, 7/42. Bring both the fractions to the same denominator. Oh, sorry, 12/42. Correct? Bring both the fractions to the same denominator. The LCM of 6 and 7 is 42. Now between these two, so 8/42, 9/42, 10/42, you can simplify. 4s are 21 times. 3 3s are 9, 14 times. 2 5s are 21 times. So what do we understand? To insert a rational number between 1/6 and 2/7, you don't have to find the decimal value of 1/6 and 2/7. What should you do? Bring both of them to the same denominator. How will you bring both to the same denominator? Using LCM. Okay, so multiply by 7. So you get 7/42. Multiply by 6. So you get 12/42. Bring both of them to the same denominator. Then you can insert. 7 and 12, 8 by 42, 9 by 42, and simplify it and leave it. So that's a rational number. Why is it a rational number? Because P by Q form. So rational number. Or as Kamalika was telling us, that mean method. If you have learned mean method in school in 8th standard, half of 1 by 6 plus 2 by 7. That is, add the two given numbers and divide by 2. Dividing by 2 means multiplying by 1 by 2. Because division becomes multiplication and 2 by 1 becomes its reciprocal 1 by 2. Dividing by 2 means multiplying by 1 by 2. Both are the same. So add the two numbers and divide by 2. That means multiply by 1 by 2. This also is a rational number between 1 by 6 and 2 by 7. I'll share all this on WhatsApp. Don't worry. You understand now in the class. Is it understood? What are the two methods? Half of whatever two numbers are given. 1 by 6 plus 2 by 7 into 1 by 2 is a rational number. Or you can bring them to the same denominator and also insert a rational number. To insert an irrational number, you have to find the decimal expansion. To insert an irrational number, you have to find the decimal expansion. So I've not shown the division here, but you should be able to find it. Okay. So I've got 0.16 recurring. And this one is 2 by 7 is 0. Whatever you see here. So irrational number, what I have written is this is 16 and this is 21. Oh, sorry, 28. Nobody's seeing the board. There's 16 and there's 28. So I have written like 19, 199, 1999, and so on. This is 16, no, and this is 28. 0.16, 0.28. Oh, I have written 19. Safe between this. 199, 1999, and so on. Right? If it's understood, I'll go to the next slide, children. One rational number, right? 17, 177, 1777, correct. Yeah. Anybody online can answer this question. Find two, all of you find here, all of you find online students. Find two rational numbers between these two numbers. I'll ask everybody. Everybody must give me their answers. Now 1 minute time for this. All of you should be ready with the two numbers in 1 minute. Yes. Aniruddhan. Tell me the two rational numbers you've written.
No, ma'am.
Anugraha,
Well, I'm working.
you've not written?
Well, I'm still working.
Yeah, who's ready here? Niveda? Kamalika? Ritsa? Okay, what's Avishya? I won't say if it's right or wrong, but I'll just take it down. Bhavishya? 359 by 100.
356.
35? Okay, fine. Then Argamai? Sahana? Renu?
Can I?
Yes, Swati?
Ma'am, I have written 354 by 1000 and 356 by 1000.
If you write these numbers, then you should simplify. Take some of the numbers so that you don't have to simplify. I told you, no, it's right. Maybe I'm sorry, it may be right, but 354 by 1000, you cannot leave it like that. You have to simplify.
Ma'am, then
And 356 by 1000, huh?
Yes, ma'am. 350.
Okay.
I'm changing it to 357 by 100. 1000.
Yeah, that's better.
And 359
Yeah,
by 1000, ma'am.
okay, fine. Okay. So you then Roshni? Ritza? Kamalika? 300? இதே மாதிரி சொல்லக்கூடாது. In fact, Swati, she's written the same thing. Okay, we'll see. It's okay. Yeah, அப்படின்னா யாருக்கும் புரியல அவ்வளவுதான். ஆனா I've been shouting, I've been coughing and shouting. என்ன? எல்லாம் ஃப்ரெண்ட்ஸ் பத்தி சொல்றீங்க. இப்ப நீங்க முன்னாடியே சொல்லியிருந்தா பரவாயில்ல. After you got the answers now, I asked you all அப்படின்னா அப்படியே சொல்லியிருந்தா பரவாயில்ல. சரி சொல்லுங்க என்ன 300? I can't take it now. அப்ப யாருக்கும் புரியல அவ்வளவுதான். Anirudhan, what are you doing? Laksha, Anugraha. What does this mean? I don't know. How do I understand this? Two rational numbers. What are rational numbers, children? Actually, you know what? I'm feeling odd. You don't feel bad. When most of you do not know the answer, that means I have not communicated effectively. Now I can't feel happy about myself. I'm now feeling ashamed. என்ன பிரச்சனை? Let me understand the problem. ரெண்டு rational number எழுதணும். Rational numbers தான் என்ன எழுதணும்? How do rational numbers look like? P by Q form, okay. Then decimal na எப்படி இருக்கும் பார்க்கிறதுக்கு? Terminating-ஆ இருக்கணும் இல்லைன்னா non-terminating repeating-ஆ இருக்கணும். இதெல்லாம் தெரியும்ல? So rational numbers na எப்படி இருக்கணும் பார்க்கிறதுக்கு? P by Q form. So integer integer-ஆ இருக்கணும் இல்லைன்னா terminating decimal இருக்கணும் இல்லனா non terminating repeating decimal இருக்கணும். It should look like one of these, right? So can't we write a terminating decimal? 0.3 को 0.34 and 36. அதுக்கு நடுவுல என்ன போடலாம் நீங்க 34 க்கும் 36 க்கும் நடுவுல என்ன போடலாம் 35 போடலாமா? So 0.35 itself is an answer, no? Terminating decimal. You know, you can change it. But 0.35 itself is an answer because terminating decimal. So we can just see 0.34 and 0.36, okay? So we were always talking about safe. So don't you think 0.35 is safe? Do you all agree? 34, 36. So 35, we have come between that. So we are in between. Kandipa 0.35 and something will be between 34 and 36. Yes or no? You cannot write 1 point. 1 point will go out of the range. You have to be within the range 0.35. This itself 0.355. Terminating decimal, no. 0.3555. This is a different number. Terminating decimal. So you can write 0.351, 0.35. You should start with 35, 351, 352, 0.353. You can write. I can say 0.35, another 5 and then 1. 0.35 or like some whatever 1, 2. It's a terminating decimal, right? Just start with 0.35 and write whatever you please. You can write like some 2, 2. It's a terminating decimal. It's a national number. Or you can, if you want to write recurring 0.35 and you can put a 1 recurring. See, if you want to write terminating decimals, you can write 0.35. You start with 35. This itself is an answer. Or you can write 351. Terminating. So rational number. So 0.351 means 351 by 1000. Or you can write 0.3511. So it is 3511 by 10,000. 0.3511. So it will be 3511 divided by 4 zeros. 1 followed by 4 zeros. Okay, now talking about Swati's answer 3. So this one is nothing but 0.357, correct? And this one is 59, correct? Swati is correct. Bhavishya is 359 by 100. So this is 3.59. Okay, Bhavishya, we have to talk about. Bhavishya says,
Ma'am, when we take as 356 by 1000, we should simplify and get the answer, right, ma'am?
correct.
Ma'am?
Yeah.
Ma'am, when we write as 356 by 1000, should we simplify and get the answer?
Yeah. If it is possible to simplify, you should simplify it.
Yes, ma'am, then I got the answer.
Okay. So talking about Bhavishya's answer, 359 by 100. It's nothing but 3.59. And Bhavishya, you've gone outside the range. And similarly, by it will be 3 point. You have written 3, 5, 6, 7. By how many zeros you put? 1000 you put. So 3.567. 3567 by 1 followed by 3 zeros is 3.567. You have gone outside the range. Now tell me, all of you, Aniruddhan.
Ma'am,
Yeah. Tell me one terminating decimal. All of you must tell me one terminating and one non-terminating repeating decimal. Because we have to write two rational numbers. So I want you all to say one terminating decimal and one non-terminating repeating decimal. Starting with Aniruddhan. Yes, Anirudh.
ma'am, 357.
Yes, 357, huh? No. Swati.
Can
Tell
I
me
hear
one
the question?
terminating decimal. Same question. I want one terminating decimal and one non-terminating repeating decimal.
Can you give me a moment? I'll think an answer for this.
Okay. Who's ready here? Yes, Bhavishya. Yeah.
0.3562.
Non-terminating
0.357.
7. Which one recurring?
7.
1. Which one is recurring? 7, 1 recurring. Very good.
Shall I say?
So she's 1 second. So Bhavishya is in the range 0.35. She's in the range. That's 3.4. This 3.6. So 3.5 is in the range. So 3.5 something she's writing 6.1. Terminating decimal. So rational. And then 0.35. She's sticking to 3.5 and 7.1 recurring. Recurring. Correct. Both are rational numbers. Terminating and non-terminating repeating decimals are rational numbers. So now the P by Q form for this one will be 3561 divided by 1 followed by 4 zeros. Are you all listening? Roshni and Prenu? All right. So Bhavashya is right. What about Swati? Yes.
Ma'am, the terminating decimal expansion is 0.357.
What's the P by Q form for this?
357 by 1000, ma'am.
Very good. By 1000. And repeating decimal?
Ma'am, it's 0.3569 bar.
Okay. All right. Nritsa? Correct.
Ma'am, Anil found a terminating decimal.
Yeah, tell me.
Ma'am, it's 3.59, ma'am. Divided by 100.
No, don't you say, don't you think 3.59 is outside the range? This is 0.59.
0.359, ma'am.
359 is correct. 0.359 is correct, which is nothing but 359 by 1000. Another number?
Okay. I will find it and I will.
Another? Okay, fine. Yeah, others? Ritsa, did you tell me? Yeah. 3. Okay, so that's nothing but 353 by 1000. Yeah. Repeating, non-terminating, repeating. Same thing, you can put 3 going on forever. But you cannot put 3 because there's already 3 here. You cannot write 3, 5, 3 recurring. Because if 3 repeats, then 5 also will repeat. Because there's already a 3 here. So you can put some other digit like 6 and recurring. Because 0.35, you cannot put 3 recurring because if there's 3, there should be 5. Yeah. Yeah, you've been busy writing, Roshni. Share your answers. 358. Repeating. 359 recurring. Huh? Very good. Correct. Now, got an idea, all of you? Aragamani, tell me. 0.35. If I teach you like that. 3565. Huh? Okay, then repeating 0.3562, which is repeating. Yeah. All right. Fine. All right. Yeah, please do this correctly. Find two rational numbers in the P by Q form. So you should not write terminating or non-terminating repeating. You can write, but then you should put it in the P by Q form. So it's better you write two terminating decimals so that you can write the P by Q form. Like if you write 0.5, 5 by 10. Write two terminating decimals and put it in the P by Q form. Don't write a non-terminating repeating decimal. It's between 0.20 and 21. Yeah. So take more digits. 202. Take more digits. 202 and 212.
Can I say the answer?
See, if you take 0.20 and 21, nothing is there, right? So take 202 and 21. Take the first three digits, and write between that. So 202 and 212. So 203, 204, 205, like that. Yeah, so 202 and 212. So you've taken 203, 205 and something. Put it in the P by Q form. So don't use 5 and 4. Because then P by Q form you have to simplify. So put 7 and 9 so that yeah, Kamalika. Now, first you tell me the decimal value you wrote 0.2103. So you have taken the first three digits, right? 202 and 212. So you have written 210. Correct. 3. Okay, this is fine. So the P by Q form will be 2103 by. Very good. 4 zeros. Yes. Another number, Kamalika. What's up? 2. You tell me the decimal value first. 203. That's all. Correct. So it is 203 by 1000. Perfect. Next. One more you should tell. 0.212. Okay. That means, yeah, okay, fine. But you're kind of entering the danger zone, but it's right. 212 by 1000. Then you should simplify it. Renu? Yeah, you wrote it already. So you wrote 0.20379. Correct? And 0. No, I'm not seeing the denominator. 0 point, okay? This is 0.205. Correct. I'm not seeing how. 0 is correct. Yeah, this is correct. This is correct. Yes. Yes, Prenu? 20? 1, no? No, see, 1 minute. I'll tell you something. 0.212. 0.202. If you take the first three digits, no? 212 and 202. You're writing 201. It's not in the range. After 202 is 203, 204, 205. Yeah, try another number. Roshni. 0.2. 0.8. Yeah. 0.2. 219, no? It's going outside it, no? 21. See, how do I know it's going outside? See, it's 0.202 and 0.212. You're writing 219. Write the range, no? See here, write the range. The first number is 0.212 if you're taking the first three digits. And the second number is 0.202 if you're taking the first three digits. 202, 212. You're writing 219. It's after 212. Yes, Roshni again.
Ma'am, can I tell the answer?
202 let's get it 203, 204, 205, 212, upper than 230. 11 is correct. 0.211. Correct? Yes. You want to say?
0.206.
2 not
206.
06. So the P by Q form will be
206 by 1000.
then you should simplify it. Cancel it in the tables of 2 and on that. Okay.
Can I say?
Yes, online. Online?
Ma'am, can I tell the answer? Sure.
Yeah, please tell me. Anugraha, why you are not participating today? Anugraha?
Ma'am, can I tell the answer?
Yeah.
Ma'am, 207 by 1000.
Who is this?
Ma'am, Anugraha.
Okay, 207
by 1000.
by 1000. So that means it's 0.207, right?
Yes,
correct. Then another number?
Ma'am, 210 by 1000.
210 by
Yes.
1000, correct. Should simplify this. You should not leave it like this. You should simplify this.
Okay.
Yeah. Yeah, somebody else wanted to say?
Ma'am, I got 2023 by 10,000 and 2027 by 10,000.
By 10,000. So that means 40. So 202 and 3 here. Very good. 202 and 7 here. Correct. Yes, you're right, Swati. Fine, children. Now you'll have to help yourself better. Now this one, two irrational numbers between 0.16 and 17. Oh. Find two irrational numbers. Irrational numbers means what? Non-terminating, non-repeating. Okay. So it should be between 0.16, 0.17. So difficult. 1617. So add a 0, add a 0. 160, 170. Because 16, 17, what is it between? It's so difficult, no? So add 1 0. Take 3 digits. 160, 170. You can add a 0, no? You're not changing the value. So 160 and 170. Between this, 0.161. Safe, no? Then you can write 0.162, 163. So much you can write. Now 0.161. It should be non-terminating recurring. I'm sorry, non-terminating, non-repeating. So 161. Then 62, 63, 64. Just start with the safe one and write whatever you want. I'll tell you again. 0.16 children and 0.17. Add 1 0. Add 1 0 like this. So now this is 160 and 170. Between 160 and 170, you can write 0.161, 0.162, 0.163, 0.164. So like this, you can write till 0.169. Okay, but these are terminating decimals. Don't write these. These are terminating their rational numbers. You should write non-terminating, non-repeating. So after 161, write whatever you want. Like you can write 02, 03, 04, and so on like that you can write. Or you can write something like 9, 91, 93, 95, 97, and so on. Write something. You start correctly. 163, you've started correctly. Now write something so that it becomes non-terminating, non-repeating. That's all. So you can write like 3 1, 3 1 3 1 3 4 1s, and like this you should put dots. When I'm explaining, Roshi is never looking at the board. Okay, Prenu, following. So first write the safe zone numbers. So 0.164, you're safe because it's between 160 and 170. 164, you're safe. Now you have to make this one non-terminating, non-repeating. So how will you make, right? So just plan something like, so you want to write 38, 39, 40, 41, and on like that. You understand something, children? Just pick something so that it becomes non-terminating, non-repeating. So it's irrational. So you can see here, I've made it. Oh. Yeah. Yeah, children, see here. So I have taken this as 160 and 170, 161, 169. I told you, no, take 1 0 extra. So it's like 160 and 170. I've taken 161 and written something, 169 written something. Am I clear, children? I'll give you some time to watch. 160, 170. So you can see my first 3 digits, 161, 169. So it is between 160 and 170. And then I've written 162, 163 and dots. Then here I've written 179, 189. So like 199 and dots. First write the numbers in the safe zone and then write something so that it becomes non-terminating, non-repeating. All right. Somebody wants to say something? Yes. Yes, yes.
Can we like, if we take 4 numbers, 1600, can I write like 16,000 and 70,000? I have lot of numbers.
Yeah. You can. You're adding 4 zeros. So 0.1700 like this. And now we are going to write what? Tell me. 0.1600 to 1,700. So you're going to write 1,615. Yes. And you can write up to 0.1699. Then 700, no? You can write. Okay, so that's about irrational numbers. Irrational numbers means you will have to write non-terminating, non-repeating decimals. So just increase your space between the numbers. 0.16 and 0.17 can be treated as 160, 170. So you're increasing the space. 160, 170. So 2 numbers. 161, 169. And then make it non-terminating, non-repeating. Yes. The first question I'm not taking up, please. I think all of us are tired. Write 3 decimal expansions that are non-terminating, non-repeating. Now, let's fill in the blanks. Numbers that have a dash or a dash. Numbers that have a terminating or a non-terminating, repeating or recurring. Yeah. Numbers that have a terminating or a non-terminating repeating decimal expansion are called rational numbers. The decimal expansion of an irrational number is always
non-terminating and non-recurring.
Non-terminating, non-recurring. There are dash rational numbers and dash lying between any 2 rational numbers.
There are infinitely many rational numbers and infinitely many irrational numbers.
Correct. There are infinitely many rational numbers and infinitely many irrational numbers lying between 2 rational numbers. So you can read this. These are the answers. Read them, children, for yourself. I'll wait for 3 minutes. Read. Done, children? Any other questions you have, Bhavishi? One second. Yeah. Between 0 and 130. So you made 120 and 130, and you've written 0. What's 0.1? Ah. 0 point, so 120, 123 and something, 129 and something, 125 and something, and then it is irrational, so something and dots, something and dots. All right, children. Where did we stop in the last class? Where did we stop in the last class, children? With some? Did I share the slides on WhatsApp? I said I'll share something. No, I shared?
Yes,
Yes.
Okay. I shared no images, children, on WhatsApp. You must follow it very carefully. Have I shared it, all of you? You all completed?
Yes, ma'am.
Okay.
Yes, ma'am.
From where should we continue? We finished this also, is it? We also be finished. We have to continue from here. Yeah. Okay. But since this is also there for the test tomorrow, now I'll give you a test, but I need to, don't work anything. Listen to me, children. Don't work anything. Listen to me. This is a part of tomorrow's test. So here, if x is equal to 4 minus root 15, find x plus 1 by x. Okay? All right. X is equal to 4 minus root 15. So then what will be 1 by x, children? 1 by
1
4
by
minus
4.
root 15. 1 by 4 minus root 15. X is equal to 4 minus root 15. Then the reciprocal of, meaning the reciprocal of x is 1 by x. So 1 by x will be 1 by 4 minus root 15. Correct? Now the denominator is irrational. So we have to rationalize it. So it will be into 4 plus root 15 by 4 plus root 15. Correct? Don't write anything. So it will be 4 plus root 15 divided by a minus b into a plus b. Kamalika, what should I write? Root 15 the whole square. Correct. So 1 by x is equal to 4 plus root 15 divided by, what is 4 square? 16 minus 15. Correct. So 1 by x is equal to 4 plus root 15 divided by 1. So which is 4 plus root 15. Correct. Yeah. So now what is x? X is given to be 4 minus root 15. What is 1 by x? 4 plus root 15. Now what is x plus 1 by x? It is 4 minus root 15 plus 4 plus root 15. Correct? So that is 4 minus root 15 plus 4 plus root 15. This gets cancelled. 4 plus 4, 8. All right. So x is equal to 4 minus root 15 is given. Next, you should find 1 by x. 1 by 4 minus root 15. Denominator is irrational. So rationalize it. How? Multiply and divide by the conjugate 4 plus root 15. Now multiply the numerators. Multiply the denominators. Then all this. So 1 by x is 4 plus root 15. Now it's easy to find. Now you know x and 1 by x. Now find x plus 1 by x and x minus 1 by x. All right. So see here. See here what I told you. 1 by x. So x plus 1 by x. This is x plus 1 by x. This is x minus 1 by x. This is 1 by x, children. This is x. So this is x plus 1 by x. This is x minus 1 by x. So it will become minus 4. Minus into minus, minus into plus minus 50, root 15. When you open the bracket. So 4 and minus 4 will get cancelled. Minus root 15 minus root 15 is minus 2 root 15. All right. Now next, how to find x square plus 1 by x square. How to find x square plus 1 by x square. Okay. So for that you can square x plus, see, you can square this one on both the sides. You can square this one on both the sides, or you can square this one also on both the sides. In both the ways, you can find x square plus 1 by x square. Okay. Online students, are you all listening to me? Is it clear so far?
Yes, ma'am, clear. Yes, ma'am.
Okay. We are talking about the next one, x square plus 1 by x square. To find that, you can either square this on both the sides, or you can square this on both the sides. Okay, so let's see that. I have worked only one, is it? 1 second, let me just see. Yeah, I've not worked the other one. Okay. So I'll do it here itself, children. I'll share all these images on WhatsApp. You can complete it later. So now see here. To find x squared plus 1 by x squared, I'm squaring this answer on both the sides. I'm squaring this on both the sides. What is x plus 1 by x the whole square? It's like a plus b the whole square, which is a square plus 2 into a into b, 2 into a into b, correct? Plus b square. Is this correct? Is equal to 64. Is this correct? What is x plus 1 by x the whole square? It's like a plus b the whole square. What is a plus b the whole square? A square. That is x square plus 2 into a into b. 2 into x into 1 by x. plus b square 1 by x the whole square is equal to 64. So x square plus x and x will get cancelled. 2. 2 into 1 is 2 plus 1 by x square is equal to 64. So x square plus 1 by x square is equal to 64 minus 2. X square plus 1 by x square is equal to 64 minus 2. So x square plus 1 by x square is equal to 62. I'll do it again if you're not very sure. Square this answer on both the sides. A square plus 2 into a into b, 2 into a into b plus b square is equal to 8 square 64. So this is x square plus x and x gets cancelled. So 2 into 1 is 2 plus 1 by x square is equal to 64. Now 2 transpose. So x square plus 1 by x square is equal to 64 minus 2. So x square plus 1 by x square is equal to 62. You can also square this. Let's do this. So square it. A square x square minus 2 into a into b minus 2 into x into 1 by x. A square minus 2ab plus b square plus b square. A minus b the whole square is a square minus 2ab plus b square is equal to minus, what is minus 2 root 15 into minus 2 root 15. Minus into minus plus 2 into 2, 4. Root 15 into root 15 is 15 and 4 15s are 60. Minus into minus plus 2 2s are 4. Root 15 into root 15 is 15. 4 into 15 is 60. So is equal to 60. X square minus 2 plus 1 by x square is equal to 60. So x square plus 1 by x square is equal to 60. Minus 2 will go to the other side as plus 2, 62. We'll get the same answer. So how to find, you should remember this. So how to find x square plus 1 by x square? You can square x plus 1 by x or x minus 1 by x. Both the ways you can find x square plus 1 by x square. Don't think if you square x minus 1 by x the whole square, you will get x square minus 1 by x square. No. Because the difference is plus 2ab minus 2ab. That's all. இதெல்லாம் பார்த்து work பண்ணணும். You should use your tuition notebook. Now I'll share the slides. No? When you're working, you should be very mindful when you're working. Don't just copy. First read the slide, understand, and then write it. And that way only you can practice. Are you all following now? What is a minus b the whole square? What's your name? Aprenu? A minus b whole square. How do you expand that? A square plus b square minus 2ab. What is a plus b the whole square? A plus b the whole square.
A square plus b square. A square plus 2ab plus b square.
Yeah. Anirudhan, tell me what is a minus b the whole square? A minus b the whole square.
A minus b the whole square, Amma.
Yeah.
A square minus 2ab plus b square.
What is a plus b the whole square?
A plus b the whole square. A square plus b a square plus 2ab plus b square.
Okay. Understood this one? Anugraha, Laksha, Swati, and Anirudhan.
Yes,
How
ma'am.
to find
Yes,
x
ma'am.
square
Yes, ma'am.
plus 1 by x square. Okay. Next, what is a square minus b square, children? What is a square minus b square?
A plus
A
b
plus
into
b.
a minus.
Very good. A square minus b square is a plus b into a minus b. A plus B into A minus B. So then what is x square minus 1 by x square? Kamalveka. A square minus B square is A plus B into A minus B. So x square minus 1 by x square will be x plus 1 by x into x minus 1 by x. Correct. Very good. A square minus B square is A plus B into A minus B. So x square minus 1 by x square is x plus 1 by x into x minus 1 by x. Understand all of you? Now what is the value of x plus 1 by x? 8. What's the value of x minus 1 by x? So what's the answer? X square minus 1 by x square minus 16 root 15. This is the only way of finding x square minus 1 by x square. I'll tell you again. X square minus 1 by x square is like a square minus b square. A plus b into a minus b. 8 into all right. Next, we have to find x cubed plus 1 by x cubed. X cubed plus 1 by x cubed. Now, this identity you do not know. Do you know what is a plus b the whole cube? A plus b the whole cube? Okay, so we'll learn it now. What is a plus b the whole cube? A plus b the whole cubed is a cubed plus b cubed plus 3ab into a plus b. We'll see this in detail in the next chapter, polynomials. Okay. Okay. Now, this is a cube, a plus b the whole cube. A cube plus b cube plus 3ab into a plus b. Memorize these two identities now. Yeah, memorize these two identities now. Memorize, children? Okay. So tell me what is a plus b the whole cube? A cube plus B cube plus 3AB into A plus B. What is A cube? What is A minus B the whole cube?
A cube minus B minus B.
Very good. Okay, so now these are the two very important identities to find x cube plus 1 by x cubed and x cube minus 1 by x cubed. All right. So now, what is x plus 1 by x the whole cube? When you cube it, root here itself. What is a plus b the whole cubed? A cubed, right? Now cube this on both the sides. Cube this one on both the sides. To find x cube plus 1 by x cube, cube this on both the sides. Just a minute, children. I'm getting a call. Just a minute. It's not very cold right now, no? It's not right. You can manage. Yeah. My class started at 5:30. Okay, so I'll just rush and come at 5:30. Then I'll just turn off everything and I'll sit down. Please come in, sir. No, come in. Please. No. Come inside. No, you can wait here. Please come inside. அப்படியா இல்ல அங்க ரொம்ப வார்மா இருக்கும் பரவாயில்லையா அததான் சொல்றேன் உள்ள வந்துருங்க கம் யா கம் க்ளோஸ் பண்ணிடுங்க மேம் யா தேங்க்யூ எஸ் children. So I was telling you to find the value of x cubed plus 1 by x cubed. We need to cube this on both the sides. X plus 1 by x, the whole cubed is equal to 8 cubed. Now we just learned the identity, right? What is a plus b, the whole cube? A cubed. So what is a cubed, children? Yeah, go on. Plus b cubed. What's b cubed? 1 by x, the whole cube. Very good. Then plus 3 into a into b. What is that? Very good. 3 into a into b into a plus b. X plus 1 by x is equal to 8 cube. What is 8 cube? 8 into 8 into 8. Very good. 512. 512. Yes. Yeah. Now online students, one of you will continue. Tell me. What after this? What will get cancelled here? Online students?
X and x gets cancelled, which gives us 3.
Okay. Plus 3 into, what is the value of x plus 1 by x? What is the value of x plus 1 by x? We already found, no?
8, mom.
8. Can we see that? What's the value of x plus 1 by x? 8. is equal to 512.
512.
Very good. So x cube plus 1 by x cube plus, yeah, continue Swati.
24 equals 512, ma'am.
Okay.
Ma'am, and then 24 gets transposed to the other side as minus 24.
Correct. So 512 minus 24, 488. So the value of x cube plus 1 by x cube is equal to 488. Do we understand that? So what we have to do? We just have to cube this on both the sides. X plus 1 by x the whole cube is equal to 8 the whole cube. So now this is like a plus b the whole cube, right? A plus b the whole cube, which is a cubed plus b cubed plus 3 into a into b into a plus b is equal to 8 cubed. You all said is 512. Now this is x cubed plus 1 by x cubed plus x cancels 3. What is x plus 1 by x? 8. We already know it is 8 into 8 is equal to 512. So x cube plus 1 by x cubed is equal to 512. And this 8 3 are 24 transposed. Correct? All right. In the same way, to find the value of x cubed minus 1 by x cubed, we need to cube this on both the sides. We need to cube x minus 1 by x. This one on both the sides. You need to cube this on both the sides. All of you understand? So, what is a minus b the whole cube? Aniruddhan? Are you there? Yeah. What's a minus b the whole cube?
A cube minus b cube minus 3ab
3 into a into b, yeah.
into a minus b.
A minus b is equal to, tell me the value of, anybody online tell me what is minus 2 root 15 the whole cubed. Take your time. Calculate. What is minus 2 root 15 the whole cubed?
Ma'am, 6. Ma'am, 60.
Minus 120.
Just minus 120. Minus 120 root 15. Okay, let me check. So what is minus 2 root 15 the whole cubed? Minus 2 root minus 2 into minus 2 into minus 2 into root 15 into root 15 into root 15. Correct? Minus here. Minus 2 root 15, the whole cubed. How do we calculate this? Minus taken 3 times is negative. Minus multiplied with itself 3 times is minus, negative. 2 into 2 into 2. 8. Root 15 into root 15 into root 15. Root 15 into root 15 is 15. Another root 15. So she was right. Minus 120 root 15. You need to multiply the same thing with itself 3 times. Minus taken 3 times is minus. 2 multiplied with itself 3 times. 2 into 2 into 2 is 8. Root 15 multiplied with itself 3 times. Root 15 into root 15 is 15. And there's another root 15, no? So the product is minus 120 root 15. Any doubt there? Okay. So minus 120 root 15. Online students? Understand?
Yes, ma'am.
Yeah. minus 120 root 15. Now, x cubed minus 1 by x cubed, x gets cancelled, minus 3 into what's the value of x minus 1 by x?
Minus 2 root 15.
Minus 2 root 15. The value of x minus 1 by x is minus 2 root 15. Substitute that is equal to minus 120 root 15. So, x cubed minus 1 by x cubed plus, because minus into minus plus 2 3s are 6. 6 root 15, correct? Plus 6 root 15. Yes or no? Is equal to minus 120 root 15. So x cubed minus 1 by x cubed is equal to, this will, you will take it to the other side, correct? So minus 120 root 15 minus 6 root 15 minus 126 root 15 minus 126 root 15. That's it. All right, children. So now what you should understand is, remember like this. To find x plus 1 by x, you should have x and 1 by x, add x and 1 by x to get x plus 1 by x. See, you should find 1 by x like this. X minus 1 by x, write x, write 1 by x and subtract. How do you find x squared plus 1 by x squared? Square this on both the sides. Or you can even square this on both the sides to get x squared plus 1 by x squared. To find x squared minus 1 by x squared, a squared minus b squared is a plus b into a minus b, correct? So we know that x plus 1 by x is here. What is x plus 1 by x? What's x minus 1 by x? So the product will give you x squared minus 1 by x squared. Then how do you find x cubed plus 1 by x cubed? Cubing this one both the sides. How do you find x cubed minus 1 by x cubed? Cubing this one on both the sides. So you remember this. In examination, you cannot think, you should know what to do. To find x cubed minus 1 by x cubed, what should you do? All right. Next is to find x to the power 4 plus 1 by x to the power 4 and x to the power 4 minus 1 by x to the power 4. Now to find this one, you need to square. See, I found the value of x squared plus 1 by x squared. Should square that on both the sides. Yeah. We have already found the value of x squared plus 1 by x squared. Earlier only we found no x squared plus 1 by x squared. Square this one on both the sides. To get the value of x to the power 4 plus 1 by x to the power 4, you must square this on both the sides. X squared plus 1 by x squared is equal to 62. Square this on both the sides. So when you square this is like a plus b the whole square. So a squared, this is a squared. This is b squared plus 2ab plus 2 into a into b. All of us are tired and sleepy. Okay, is equal to 62 squared. Correct? That's all, same thing. And then you'll transpose. This will get cancelled and plus 2 will come to the other side and you'll find. So to find the value of x to the power 4 plus 1 by x to the power 4, you should square this one on both the sides. X squared plus 1 by x squared is equal to 62 on both the sides. And this is very important. To find the value of x to the power 4 minus 1 by x to the power 4, this is again like a squared minus b squared. A the whole square minus b the whole square. See it? X to the power 4 is x squared the whole square. Do we understand this? Online students?
Yes, ma'am. Ma'am, I have a doubt in the fourth question.
Yes. Fourth question meaning fourth subdivision, huh?
Yes, ma'am.
Yeah, tell me.
Ma'am, can we write x square minus 1 by x square as x minus 1 by x the whole square?
Come again. X squared. No,
And can we write-
no. How can you see here? Okay. Fine. What is x minus 1 by x the whole square? Swati, expand this.
X square
Expand this one.
minus 2 into x.
1 minute. I'll just write it. Yeah. What is x minus 1 by x the whole square?
X square in minus 2 into x into 1 by x
Yeah.
plus 1 by x the whole square.
Correct. Correct. So what does this give you?
X square minus 2 plus 1 by x square.
Now you are saying that so x minus 1 by x the x minus 1 by x the whole square is x square minus 2 plus 1 by x square. Then where is it x minus 1 by x? Sorry, where is it x square minus 1 by x square? It's not x square minus 1 by x square. You can see it here. Swati, when you expand x minus 1 by x the whole square, you're getting 3 terms. The terms are x square minus 2 and plus 1 by x square. Then how is this equal to x square minus 1 by x square? No, I'm not clear.
Not equal to x.
Yeah, when you actually expand, x minus 1 by x square, we are getting x square minus 2 plus 1 by x square. You're saying x minus 1 by x the whole square is x square minus 1 by x square. No, where are they equal? See, where are they equal? When you expand x minus 1 by x the whole square, you're getting 3 terms. And that is not equal to x square minus 1 by x square.
Yes,
Okay.
ma'am, understood.
See the last. Yeah. So see the last one, children. Okay, so it's like a the whole square minus b the whole square, which is a plus b into a minus b. X to the power 4 is x square the whole square. This one is 1 by x square the whole square. Correct? So it's like a square minus b square, which is a plus b into a minus b. So a plus b, x square plus 1 by x square into a minus b, x square minus 1 by x square. So we've already found those values. We've already found those values earlier, you know. See it? X square plus 1 by x square, we already have the value here. X square minus 1 by x square, we already found the value. So substitute the values and multiply and get it. All right, online students.
Yes, ma'am.
I've given a very important note below here. See, these two are not equal. X to the power 4 plus 1 by x to the power 4 and x plus 1 by x to the power 4. They're not the same. So when I share the slides, go through the answers very carefully. So tomorrow you will see 3 tests in your, you can see today, I've already scheduled it. In the upcoming exams, you can see 3 exams. In the upcoming exams, you can see 3 exams. You can take them tomorrow. You must finish all the 3 exams before the class on Friday. Before the next class on Friday, you should finish all the 3 exams. All right?
Yes, ma'am.
Yes, ma'am.
Okay. All right, online students, Aniruddhan, Lakshya, Anugraha, and Swati. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you. Thank you, children. Good night.